Good morning. We'll be going live in just a few minutes. Now, just before the stream, while people are joining the channel and what have you, I thought I'd give you a quick introduction to what's coming up next. That is next in the future, so to say. Now, I'll be doing a stream at the weekend. We'll be playing some Famicom games like last time. I warn you, I'm not the greatest game player these days because I do it so rarely, but there's a lot of chat. I make extra special effort to talk to the people who are in the chat. And I've actually changed the settings of this stream. We're now using ultra low latency, so I think there's about a 5-second delay between the video, between what's actually happening on my screen and what you'll see on yours now. So hopefully that'll make the chat a bit more interactive. Still working things out this end. Now, we'll be playing Famicom again this weekend. I was hoping to use Famicom Disk System, however, my Famicom Disk System is broken. The belt has snapped in it. I tried an alternate belt and it jammed. I've got some more stuff on order. I've actually got a hardware emulator now, so we could play Famicom Disk via the emulator, but I thought I'd rather wait a little while, try and get a proper belt and see if I can manage to get my real disk system working. But that'll be coming up at some point, so we'll be playing cartridges again this time. Now, I'm planning a surprise stream on Tuesday. It's a national holiday in Japan on Tuesday. It'll be around lunchtime in Japan, which will be early evening in America, so around 6-7 hours from now, wherever your territory is. The reason I'm doing it a few different times is I want to try and do the odd stream for everyone, depending on what country you're in, because sometimes it'll be impossible for some countries. So, hello Rob, it's very kind of you to join me today. Okay, well, yeah, I almost always watch YouTube in that way, working while I'm listening. So, you know, I have no expectation that people have to, in any sense of the word, to chat along. So listening along is absolutely perfect. I'll keep talking away as long as I have things to say, and I'm sure I usually will. I'm not known for being particularly quiet at the best of times. So anyway, so that's the my plans for the gaming. I've not decided what the Tuesday stream will be. It will depend if I need to get any programming done or if it's just a case of I fancy playing some games. One thing I am planning for the Famicom is I have the Famicom Basic, which is a full keyboard with a manual, and you can program little games and programs on it. So at some point I want to do a stream of actually playing with that and just see what I can knock up in 2 hours or something of that nature. So that should be quite interesting. Of course, the big one I'm planning is the Halloween stream, which is the weekend, the Saturday after Halloween, and I'll be playing the 7th guest on that one, and I'm reading through the book of that one again, and I'll be trying to get as much technical information on the game as possible. So that's something I've got planned there. We're not quite at 1:15 yet, but so today we're going to be doing some CPC once again. Maybe we'll be doing the Phoenix 256 as well. I said before I was having some trouble with the Phoenix 256 emulator because the 0-page entries, the ink command on the 0-page entries weren't affecting the processor flags correctly. Hello, welcome Juan. Very kind of you to join me today. So yeah, the Phoenix 256 is now working, and fingers crossed so is my emulator. It's always a little bit touch and go, shall we say. I changed my assembler, same assembler but the newer version, and I tried to run it yesterday and it didn't work, and it turned out I needed to install some new C++ libraries. So yeah, it's always a bit difficult, but I think it does compile again. So maybe if we have time, maybe we'll be doing some playing with the Phoenix 256 once again. This stream's around 2 hours because I do it before I go to work. So it's 5:15 now, and I have to leave for work around 7 o'clock. So we're on a kind of 2-hour clock here, or an hour 3/4. Okay, well let's turn the proper screen on here. There we go. So I've got my bitmap multi-layer, which is a tutorial that I will just run it for a bit of fun. This is a tutorial I wrote just last week. I had originally been thinking of it for a live stream one, but it was a little bit more complicated. I think we did. Did we do this on live stream? I can't remember now. Maybe we did. Anyway, so this is we did, didn't we? So this is the final version of this tutorial here. So you can see here we've got 2 layers, and the top layer is moving over the bottom layer, and this is the regular version, but I have made some that will work with 3D glasses. I did do a screenshot of this on Twitter. So this tutorial will probably be coming up to the Patreons next week, and it'll be coming up on to everyone else in a few weeks. I tend to give the Patreons everything the second it's finished, and then with everyone else they come in order. I try to space out whatever videos I've got ready over the weeks so that YouTube's algorithm works the best for me, but everything does come out eventually. So what are we going to do today? Well, this is a kind of idea. Science explosions. Oh, brilliant. That's X68K. That, you mean the Sharp X68000 science and explosions? That's one that I only vaguely knew of, but it's a 68,000 PC. I mean, it looks and works like a PC, so it's a very interesting one. It's very nice to hear that I've encouraged someone to give programming a go in any sense at any level, to be honest, because the hope is that people can get some enjoyment and also maybe learn something new from trying these things out. And I often found that it wasn't as hard as I thought it would be, and in a lot of cases when I'm learning a new system, for example, actually doing the programming isn't too bad. The difficult thing is getting the environment set up, getting the assembler to compile to the emulator, getting Hello World on the screen. And once, okay, but you got two of them. I got two of them, but one of them doesn't switch on, so I don't think that one counts. So I've got one working one, but yeah, they are quite a nice system. We'll probably do some live streamed gaming on the X68000 at some point, assuming my X68000 still works, of course, because sitting in the cupboard for 6 months, you can never be quite sure. But, okay, so let's just compile this example here. Oh. And just... Where's my window gone? Oh, the layering doesn't quite work as nicely as I'd hope on WinApe. Sometimes you try and alt-tab it to the front and it doesn't come to the front. Okay, so here we've got a very basic example here. We're showing the sprite to the screen. Now, what I want to do today, and this comes from a comment that was posted on my YouTube channel. Someone was asking about reversing a sprite, so showing it facing the other direction. Now, each pixel on the CPC screen is 2 bits, so there's 4 pixels per byte. So what we're going to need to do is we're going to need to flip those pixels horizontally so that the character faces the opposite direction. So the little flame will be on the left-hand side. So we're going to need to do that at the byte level, taking each pair of pixels for the color and shifting them to the opposite side of the byte, and then showing the byte to screen. Or alternatively, I think possibly saving it into memory, because then you can show it to the screen very quickly once you've got it prepared in memory. This might be very useful if you had a tape game, for example, because you only want to load the sprite once from the tape to save time, and then convert it to face the opposite direction in memory. Now, I'm no major expert in this kind of thing, but before I wrote the Chibi Akamas game, I did go through a lot of old games in an assembler, in the debugger, sorry, in WinApe. You can actually see the graphics memory. Oh, press the wrong option there. So if we go to debug, find graphics here, you get this wonderful mess here. And this is actually the system memory. I think you can hear this is probably the Amstrad text. This is the text screen. So you can actually see the sprites that are in memory. And so I did this to just have a look around at various games and see how they worked. And to my recollection, and as far as I know, if a sprite faces in 2 directions on the CPC, then it's in memory in 2 directions. So that's just because the CPU isn't that fast, and it's going to be a lot slower to flipping the sprite around. So you don't want to do that in real time. You want to have a copy in memory and facing both directions, because even on a 64K system, you've probably got enough memory to do that if you've got enough memory in general, because say background graphics, I guess, are probably going to take more and things. So we're going to convert this basic example here to flip the graphics. Now, this is mode 1, 4 color mode. There's also mode 0, 16 color mode. And we're going to create code to flip both. And the code is going to have to be different to do each job. Now what I'm thinking is we should have a macro. So we're going to create a macro called flip mode 1. And we may do mode 2 and we'll do mode 0 definitely. We may even do mode 2 because mode 2 would basically be the ZX spectrum. The same, very simple layout, 1 bit per pixel. So you just literally take what's on the right, put it to the left and vice versa. Mode 1 is each nibble of the byte is a bit plane effectively, and mode 0 is really weird. The bits are all over the place. It makes no sense to me, but I'm sure there's a good reason for it. I can't remember the end of macro command. I think maybe it's endm. So we're going to put this here. So it's going to effectively convert A into the opposite direction, and we're going to need some kind of registers to work with as temporary variables. We don't really have any. Okay. Just trying to think what to do. Well, we'll use BC for now, so we'll do a push of BC. A pop of BC. So we've got the accumulator, so let's load B with the accumulator, and at the end we'll load the accumulator with C. So let's load B with 0. No, that's not right. B with accumulator, C with 0, and then what we're going to do is we're going to have to split each 4 of the pixels out from the mode 1 byte and move them around and then store them in C. So we'll do L load. We don't need to do a load first, so if we do AND 1 0 0 0 1. I've been thinking about what the best way of doing this is, and unfortunately I can't think of a particularly efficient way of doing this. We're just going to have to take each one of the 4 pixels and just do enough rotates to get them into the right position. I think RRCA is as good as anything at this point. It's a 4 tick command. I've got this laminated sheet with all of the commands on them and how many ticks they take and things like that. So in a case like this where I could do RRCA or RRA and so on, I just will check the sheet just to check the particularities of the command. I do get confused, you know. I tend to be okay not putting RRR commands in and things, but I do sometimes get confused which is RRCA and RR and RL and SRL and things with Z80. They do easily get mixed up in my mind, shall we say. So that's the first one there, and then we need to do LDA, B, and get the second pixel, and then we need to shift that 3 times. This is going to be slow. If anyone can think of a better way of doing this in Z80, please speak up and I'll do it. I do have an idea of how to store this mask in a separate register, but for now I'm just going to try and get this working. Okay, so that's the third. Yeah, looks right. Is that right? Now this one needs to go No, that's not right, is it? That one needs to be 2, and that one needs to shift to the left once. Blindly copying my code here and not thinking it through properly. You'll have to excuse me the odd mistake. It is 5 AM in Japan. It's maybe a little bit tired. So that one needs to be 3. That one needs to be 2. That's 1, and that's... that one needs to be 3. And at that point, we just want it in A. Okay, let's compile that. No errors here. And if we do call into row. Okay, well that's not worked. I've obviously made some very silly mistake there. The wrong places there. So this is bit plane 0 in mode 1, and this is bit plane 1. So my bits were a bit out of order there, which is why we were getting that, whatever that is. What's going wrong here? Left. I'm clearly doing something very stupid here. I can't think what it is. So rotating to the left 3 times, or in C. Okay, yeah, I know. Okay, so this is flipping my bits, but I need to read the source data the other way, right, don't I? I need to do... No, I need to write to the screen in the opposite way, so I need to do dec HL. Just trying to think this through. So... yeah, okay, so if I do dec HL here, and where were we drawing on the screen? Okay, so we'll just need to change the screen location, otherwise we're going to make a right mess here. So if I just compile this here, let's compile that. Okay, we're nearly there. There's a pixel missing there. So what have I done wrong there? Why have we got a pixel missing? That should be loaded. I should be loading A into C. I was loading from C into A, which, because I was loading the B afterwards, was completely redundant. Okay. Still something wrong. Still something wrong. What am I doing wrong? Rotating to the right 3 times here, and then loading into C, loading from B. It should be just once, shouldn't it? It should just be once. think there's still a bug in that. I'm not sure. Let's just load up the original as well. Let's just do a comparison here. So I apologise, I know the window just went strange there. So what I've just done is I've just taken a screen capture of the correct sprite and stored it into OpenView there, so that now I've got a reference image so that when the next one comes out I can have a look and see if there is any bug with it or not. Because with the colours all messed up here, I can't quite tell. No, actually, I think that's correct. I think that is correct. Some of those vertical yellow lines I thought were maybe some kind of graphical glitch, but I can't see any problems there. I think we got it. So that's the first example working, I think. Okay. Brilliant. Okay. Now, I'm just wondering whether we'd be better off using IX instead of that push and that pop. Now, I don't know if you can hear this kind of wobbling sound here. That's my laminated plastic sheet with all of the assembly commands on it. And so what I'm doing here is I'm just checking what a push and a pop take, and they take 11 ticks each, 10, 11 ticks each. And then what I'm going to check is what a deck of IX takes, and it takes 10. It takes 10. And an IY takes 11. So what I'm going to do is, at the moment I'm using B and C as my loop counters here. I'm going to change these to IX and IY, because by my maths that will save me around 10 ticks per individual per byte basically. So we'll change this to IY, IXL, and we'll change this to, now let's change it to IYL, because it is the vertical counter. We'll change this to IXL. Now the other option would be we could use the shadow registers. I think the EXX command, which swaps in the shadow registers, takes 4 ticks. So I think that would be 8 ticks to do the equivalent of what we're doing here with IX, but I tend to avoid that because the firmware on some of these systems doesn't like it, and also some of the systems, the Game Boy for example, doesn't have shadow registers. So my my logic is these days is don't use the shadow registers unless you've got absolutely no choice, like on the Computer's Links, and just leave them for the firmware. And also just don't come to rely on them, because on some systems they're simply not there. So I use the shadow registers in last minute optimization or extreme desperation basically, but I will use IX and IY where I can within the code. The Spectrum, for example, the firmware uses IY, and on the TIE 83 I think IX is used, so you have to be sparing with them, but so we're decking IY there, and we can now remove our push and our pop here. You saw me put a apostrophe in there. That probably should tell you I've been coding ASP Classic recently. That's what happens when you program BASIC and ASP Classic. You end up putting apostrophes and everything. And then I go to my basic code and I put semicolons in everything the next day. And then my C# code as well, I put the wrong commenting statements in it. every day I'm programming a different programming language, and every day I'm messing them all up because I've forgotten what programming language I'm programming that day. So there we go. So our flip routine works now, and we are no longer needing to protect the BC register with that push and that pop. So that should be improving our code quite a lot here, because we're now we're saving that little bit of performance. Now I suppose if we were going to go really crazy, we could do something like instead of using DE as the destination and DE as the source and HL as the destination here, we could use HL as the source and DE as the destination, because we could load B straight from HL, whereas with DE we can only load it into A, if my memory serves me correct. So I think that's going to work quite nicely. Now, one optimization I had thought of that we could in theory do is use a mask, use a register for the mask here, and you have the mask in one of the middle positions that all of the bits have to pass through at some point. So for example, if we stored that as the mask in a register, we could then just do an AND with that register, but we don't really have any registers left. So I think we're going to end up saving a byte here and there, and then losing the same byte here and there. So I'm just going to leave it as it is. I think that's pretty good. So okay, so what we're going to have to do now is we're going to have to create a mode 0 sprite. Now I think we've already got one, so let's have a look. There's all sprites. Or CPC 16, that looks like it. I wonder why the names are different. Ooh. There we go. So that's a mode 1 format sprite. So we need to put that here and run that one out. I'm not pressing anything. Shift print. I'm trying to remember the command to screenshot just the current window. I thought it was control print screen. No, I'm wrong again. And that's so again, I'm just taking a print screen of the current window. So if you just bear with me a second here. So I've just copied a reference image into EarthenView, and I'll have this off screen just so that I can have a look and see, so I can check the individual pixels and see if what I've done is correct or not. So we need an alternate version of this called flip mode 0. Okay. And it's going to need to be here as well, of course. So let's open up. Oh, it's already open. What I'm going to look for down here, I think somewhere we've got the layout of the screen. Here it is. Oh. So this chaotic mess here is the mode 0 screen pixel format. So bits 0, 4, 2 and 6 are the right pixel, and 1, 5, 3 and 7 are the left pixel, and they're not in order, so it doesn't even use consecutive bits for the resulting bits of each pixel's color. Again, I don't understand that. I'm sure there's some logical reason if you look at the actual silicon that produces the image or something, but it makes no sense to me. I mean, those bits are backwards to my eye, but anyway, it doesn't matter. For our case, I think all we're going to need to do is take alternate bits. So 1 0 1 0 1 0 1 0. That's right, and then rotate that to the right once and load that into C, and then take the opposite and rotate that once to the left, or in the last one, and then I think that'll be it. Or maybe not. Well, our character has flipped, but the colours are the wrong way around. We've changed all of our colours. No, I've missed. There's a bit missing or something. Let's have a look. Let's see what I've done wrong. Have I bit shifted them the wrong way? Rotate to the right, that looks right. I have just noticed I'm loading C with 0 here. If I was ORing at the first stage, I'd need to do that, but I'm not, so I can take those out. So 0 2. If I've got these the wrong way around, I think I'm maybe reading this backwards. Let's try that then. There we go. So that looks like... No, that's not right. The colours are right now, but the pixels are wrong. The pixels are wrong. Yeah, okay. So that needs to be a rotate left, and that needs to be a rotate right. What's wrong with my emulator? Screen just locked up for a moment there. Okay, you'll have to excuse me, I'm obviously being very stupid here. So that's... Is that correct? No, that's not correct anyway. Let me just check my chart of what the pixel layout is. Maybe I'm forgetting something about... seeing it. I'm seeing what's wrong. Two, 3, 4, 5, 6, 7, 8. So we've got all 8 pixels there. Okay, I'm going to need to think about that for a little while. So in the meantime, let's do the mode 2 version. Now this is effectively going to be the same as a Spectrum version. So if I just rim this out here, and we've got a raw ZX option here. So this is a black and white Spectrum sprite. And this should do quite nicely for our mode 2. Oh, I'm there. Ah, okay, so the width, it's half the width because with the mode 0 sprite we were actually halving the pixel. The pixels are twice the size, but my sprite editor compensates, so in this case it doesn't. So our character will appear rather squashed. Okay, anyway, so let's do this one here. If I just go down to the bottom here, we put our ZX sprite in here. Hang on a minute, why have we got that? Why is that? That should be rammed out. Hang on a minute, is that why my code wasn't working? That was why it wasn't working. There was a piece of code that should have been commented out. So there we go. So that mode 0 version is working. It was just I'd accidentally left some code in. Okay, so that's a pleasant surprise there. So we'll try our Spectrum version now. That's mode 2 version. Sorry, mode 2. I don't want to speak the unspeakable system in a CPC stream. It's a joke. It's a joke. I've got nothing against the Spectrum. So we're going to load mode 2 here, and we need a macro for mode 2. But for starters, we'll put nothing in it. We'll just do that. Flip mode 2. But we do need to change this to a 6. Now it's coming out backwards because we're moving through the destination backwards, but the pixel data isn't being flipped yet. So that looks right. And so what we're going to do is we are going to do the same as before, just with an awful lot more bit shifts. So we will take one bit at a time. We'll do RCA. 7 time. Oh well, and actually, we can rotate it to the left here, so it'll go off the top hand side of the byte and go back to the bottom, because we need that bit to move all the way to there. So doing a rotate to the left will be faster there. And then we need to take that byte, that bit there, and we need to rotate that to the left twice, and that will move it to that position there. And then we need to all in C to get back our previous one. And then at this point we're now going to rotate to the right. I don't know if you know this is some fun trivia, you probably do, but apparently the Z80 instructions are all strange compared to other assembly languages, because the Z80 bytecode is, let me get this right, it's backwards compatible with the 8080. I think that's right. So the Z80 was a kind of unofficial remake, or an vastly improved remake, albeit, of the 8080 by Intel, and because of the laws at the time, they could use the same bytecode for the same functionality, but they couldn't use the same terminology in the language, so they changed. The move commands became LD commands, the rotate commands, ROR, became RRCAs and things like that. So that's my understanding. I did read that, so yeah, so it's quite frustrating sometimes to, like the syntax for the load command is, goes from right to left, whereas move commands go left to right in most cases, and that is quite frustrating. But as I say, my understanding is that it's essentially my understanding is that, as I say, it was done for legal reasons, so that they could build a byte compatible 88 with the 8080 without being subject to any legal issues. But yeah, let's say it's quite curious. I can't initially think of any other case that happened. I mean, there's lots of other processors that have some level of compatibility with other ones. The 6809, for example, is backward compatible with the 6800. That's different though. That's source compatibility. With a few minor tweaks, you can compile the source code. The bytecode is different. So I guess that's kind of the opposite. But in each case, it seems to be backwards compatibility with backwards compatible with the thing that no one really cares about. I mean, maybe that's unfair with the 8080. The 8080 was possibly more popular than I'm thinking. Of course, the Z80 was hugely popular, but with the 6809, the 6502, to my knowledge, had already gained very large control over the industry. So it would have been the 6502 you would have wanted backward compatibility with, in some sense, rather than the 6800. But what do I know? I don't know. It seems very strange to me, but maybe I'm wrong. So there we go. And then we're going to continue here. It's interesting. I've seen some documentation on the 6809, which apparently the developer of the 6809 says they were aiming to create a chip that was like an 8-bit version of the PDP-11, which I mean, I guess in some ways I can see it, but when you look at something like the 68000, you do get the feeling of this was really influenced by the PDP. But with the 689, not so much. I mean, it's not to say it's a bad processor by any stretch of the imagination. It's a very good processor, but it doesn't immediately strike me as being the case. But I say the original designer says it is, so I have no reason to believe they made it up later on. So I guess it is, but so it's an interesting one. I've not done much. I want to do some Vectrex programming at some point, just because I find the analog nature of the Vectrex's screen quite fascinating. But I do want to do that at some point, but at the moment I just haven't had time to really delve into it quite more deeply. But it's an interest. I've got all these low B. It shouldn't be here. It's a interesting system, but when I was programming it, I forget what the command. I think it was increment X or something. There was a really common command that I'm completely used to using that's missing, and I was scratching my head, and I had to look online and try and figure out, well, this command that I'm, completely, basically dependent on, it's not there. What's going on? Deleted these. These are the wrong way around. These should be loading A with B. So I don't know. I don't know what the design choices were. Why some commands were removed and other commands were put in. Well, I mean, obviously it's pretty obvious why commands are put in, but it might be the case that I just need to change my programming method with the 6809 a little bit and stop trying to treat it like a 6502. I'm not sure yet, but. Not there yet. Okay, I'm obviously got some of my bits mixed up, so we're shifting that one to there. We're shifting. That's not right. That should be 3. So that needs to go to here. So we want to change these to rotates to the right. And this one, that's a rotate to the right. That one's a rotate to the left. So I think that one's going to need to be 3. 1, 2, 3 up. And that one's going to need to rotate once. Needs to rotate right 3 times. And that needs to rotate to right once. That looks about right. I'm pretty sure that's right. Yeah, I think that's right. So there we go. So we've created a flip routine for all of our systems here. So the last thing I'm going to do then is let's take this code here and we'll go to our Z drive here, fake Z drive, and we will load up Notepad++. We're going to create an equivalent version for the ZX Spectrum because we've done all the work now, so why not take the credit for it? So the final tutorial is going to be flipping bitmaps on the Amstrad CPC and Spectrum, and we'll just add the Spectrum at the end as a sort of as a little bonus. I'll get the, just bear with me, I'll get it on the window properly in a moment, just as soon as I've got this open. ZX Bitmap Advanced here, Get this in frame for you. I have to turn the large fonts every time I start recording a tutorial, and then turn them off every time I finish, so that's how I do things. We need our macro in here. I think the syntax is correct here for Vasm. I think it's the same. And so that's the color bytes. We'll leave that. The colors were solid filling the character anyway. But we've got a problem here. We're using an LDIR here, so we need to replace that with loading A from HL, loading BE from A, and ink HL, ink BE. No, I don't think we can use IY on this one because the Spectrum firmware uses it. So and then if IX isn't 0, we're going to jump back up here. Now our flip mode 2 command is in the wrong place. It needs to be there. But we need to do it. We need to go the other way. We're going the wrong way. So we need to go right to left because our sprite is flipped again, and we just need to check BC is going to be in a good enough position here. It is, because our sprite's 6 wide and we're drawing it 10 across, 16 across, so that should be fine. I'm not seeing any updates to the chat. Just if that's correct, if no one's talking, that's absolutely fine. But the last thing I can see is Silent Explosion saying they've got an X68000. So if other people are trying to chat and for some reason they're getting missed, I apologize. Hang on a minute. Why is this window on top chat? It should be on live chat. I can't see anything there anyway. Hopefully I'm not missing anyone. Okay, so let's compile this. My compile button is now different. It's F9 on WinApe and F6 on Vasm, so I often make mistakes there. And my build window is just running away here. Okay. Where am I compiling to in RAM? 8000. Well, first of all, I think that's probably an emulator problem. So let's try this version first. Just try it and check we can compile our as I've said before, I've had to make some changes to 2004-576. That's wrong. That's wrong. It should be 32768. This is the emulator's configured to compile from 7000 because I had to change it for Chibi Aliens. So let's try the tap version. That'll be the one. Now this little laptop that I'm using for live streaming is pretty good, but you do, there we go, that's working fine. But you do notice the speed difference, and when you notice speed difference, this difference is huge. That assembler was just taking a little while to plod through building the tape image. It doesn't take any time on my i7. The other thing is the Phoenix 256, which I'm still hoping to have a little look at in a moment. That takes 20 seconds sometime to load up on this machine. It doesn't take a single second on my other machine, and the other machine should be around 3 times the speed. in theory. I don't know whether maybe there's a discrepancy there. Maybe the SSD is faster or something. I did upgrade my my data. Oh, there we go. Okay, so our Chibico character is flipped, but I need to change the color information. So we need to change that to a deck as well. And there we go. So there's our Chibico flipped. So we've now got our character flipped around on the spectrum as well. The pixel coding in Amstrad. Do you mean the Juan, when you refer to the pixel coding in Amstrad, do you mean my code could be better, or do you mean that the pixel layout on the CPC memory itself? Just could you clarify for that for me? Getting warnings, can't create disk files. I don't care about that. I think Drive 2 has a disk in it. Just bear with me a moment. I'll back a moment. I just need to get a apologise for that. Just I suddenly start coming down with nasty allergies at this time of year in Japan. I don't know why. Okay, so that's our Z80 programming out of the way. So now I'm going to move to this N drive, and this is 65816. So we're going to have a quick play with the old Phoenix, the Phoenix 256. So here's what we've got now. So we're finally in a position where we can start doing things. So I've created these new commands, inc BCU and dec BCU, and the U, I guess, is upper. This is I based this on EZ80. The reason for that is I use the 0 page like the Z80 in general, defining these ZB, ZCs, and so I was originally using BX or something like that, but I thought, well, yeah, true enough. Yeah, that's a good point. The using a lookup table. Yeah, I hadn't thought of that. Yeah, very good point. Just thinking that. I'm just thinking what the cost of that's going to be. Apart from 256 bytes, you know, how much of a saving that would give. I guess quite a lot. Yeah, it'd be pretty much instant, wouldn't it? So the question would be is how much memory are you going to take with all of the flip sprites versus how much memory is it going to be more than 256 bytes? And I guess the answer is almost certainly going to be yes, it would. Yeah, okay. Well, I'll have a go at that as well. I'll maybe start working on another version that uses a lookup table, because that's a very good point. That's almost certain to be the best option overall, isn't it? Okay. Well, that can be for another time then. So we're going to just have a look at this code here. So we're using HLU as a screen memory pointer. We've loaded it with B and all those 5 zeros there. So that's our screen memory. And then we're loading BC with the byte count, and I'm loading it with 9,000 here. And so what I've done is I've stored the X register into this memory location here, incremented the X register. And that is that's basically just filling the screen memory with consecutive bytes here. So if I just run this here, it didn't take too long to load. Maybe it's feeling better today. And then if we do restart here, there we go. So what we got here is, I think, assuming this code is working correctly, is consecutive bytes written to the screen. Now, most of these are black, and the reason for that is that I haven't defined any colors yet. So let's just move this out of the way just a little bit. I'm going to keep it on screen again because I'm probably going to have more layering problems. And if we go into emulators, Phoenix IDE, manuals, I think. This one, the memory map. Let's have a look at this. Oh, well done. Well done. We're trying to browse the web, are we? My firewall thinks otherwise, so bad luck there. Apparently, it looks like Edge can't open a PDF without access to the internet. Not quite sure why that would be. Maybe that's why you're losing to Chrome. I liked how recently Microsoft have changed the the engine that does the rendering in Edge to the Chrome engine, rather than open sourcing it. You know, it's like, yeah, you're losing to Chrome, but the world does need more than one rendering engine. So it would have been nice if you could have open sourced the one you've made and let the rest of the world use it, rather than just Windows 10. But instead, they've decided to ditch it and go to the same engine that Chrome's using. WebKit, isn't it? Which I've got nothing against it, but I would quite prefer it if there was no majority. Well, not a majority. I don't want anyone to be the 99% supplier of web content from the web browser point of view. I would prefer it if there was someone at 60%, someone at 40%, and someone at 10%, you know, or something like that. They don't even add up to 100. Anyway, as I say, it would have been nice if they'd have open sourced it, and then maybe the Linux users could have had a go, and maybe their rendering engine would have become more successful. Yeah, I'd say I don't really have any complaints against Edge. I've never really used it, but I tend to use Linux machines for my web browsing, and so it's like. But it's like I've never had any major complaints against it. But it just seemed like, well, you've got a thing, you've put a lot of work into here. Couldn't you make it available to everyone? But knowing Microsoft, it probably used hundreds of components from the operating system, like VB script in. I've heard that the reason that VB script in Access can't be mimicked on any of the other on LibreOffice and things is because it's actually parts of the operating system that are doing the work and not actually parts of the Office suite, which is, well, that's a bit weird. But at least with Office, you know, it comes basically from Office 97 and Office 2000, you know, back decades ago. But Edge was all written brand new just a couple of years ago, so I'm not quite sure why. I would have hoped they wouldn't have still designed things to be tied that low level to the operating system these days, because I think most people agree that's not the way to do it. Okay, so anyway, sorry, I'm completely getting sidelined into a rant about operating systems and web browsers there. I apologise for that. So what I'm looking at, this one isn't the right one. Do I actually have anything that can open docx installed on here? Oh, open off. Oh no. WordPad's having a go. It's having a go. It's failing. It's failing to have a go. It's just locked up. Oh no, it's managed it. Sorry. Got there in the end. And in the end, let's have a look at it. So I think this is the better document. The other one was the PDF doesn't seem to really help. So this is what I've got so far. This is what we got, and it's got me there so far. Memory mapped, right? So AF memory mapped IO. Oh, let's scrolling is going a bit crazy there. It's my scroll bar. There it is. So border color is it's AF00 to AF. Oh no, AF05. Background pixel. Where's the rest of the colors? Sprite is split into foreground 4 bits and background 4 bits. That doesn't sound right. I think that's for a different screen mode. A little bit difficult to find what I'm looking for the information on the colors here. Now, I've defined a few of them here. AF200. I don't know, something. This is one of those feeling like an idiot kind of stages where I can't find what I'm looking for, how to set the palette. Now my understanding is that I'm in my recollection is I'm in a bitmap mode here, and AF2, here we go, graphics mode lookup table 0. So that was, they're referring to it as a lookup table. So I don't know if that's then jumping these references here, jump down to these references here, maybe. I'm not entirely sure what that means. Okay, well, let's move that off the screen here, and let's try and actually set a color. So I'm setting these three to 192 here. So let's try as a test. Let's just try setting the second one to 32. And if we compile again. Now, okay. We don't need to close this emulator each time. We can just do a restart. So we've just changed the background color to blue here. And if we change this to 192. Okay, so that's changed the colors there. Okay, so what I'm going to do now, So I think this is red, green, blue alpha. I think there's 4 bytes per entry, but the alpha doesn't actually do anything. So what I'm going to do now is try and set a different pixel, a different color in the entries here to bright white, and we'll see if we see that on screen. Yeah, there we did. So there we go. So that's our pixel there. So it's referring it to as a lookup table, but it just seems to be a pretty typical palette here. So I don't know why they referred to it as a lookup table, but whatever. So let's change this one to 0. And we'll compile again. Okay, so I think that's alpha. And that's red. And I'm pretty sure this one's going to be green. Okay, so what I'm hoping to do is create a set palette function basically. And as you saw there, I'm still used to programming Z80 at the moment, so it's going to make things a little bit tricky. Okay, so we're going to need to set the top byte of I can't remember what my top register is called. Is it HLU or HU? I'm calling them registers. Yeah, it's quite interesting. I've always thought of the 0-page entries as registers. Well, I call them registers just because I treat them like Z80 registers. But, you know, I know that's technically incorrect and I constantly have to correct myself in the tutorials and things. But when you look at the TI-99, the TMS 9900, it uses a bank of, I can't remember how many it is it 32? 32 registers, or I think it's 32. It uses a bank of 32 bytes of memory as, is it 16 and they're 16-bit? Anyway, it uses a bank of memory, and it in the same way as like a mini 0-page, and it actually refers to them as registers. So I was feeling slightly vindicated in referring to the 0-page on this 6502 as registers after seeing that. But as I say, no, Juan, there's nothing wrong with your English at all. It's my paranoia kicking in that maybe my code wasn't as good as it could be. I suspected you did mean the Amstrad C hardware, but I hadn't thought. I'd forgotten about the possibility of using a lookup table. You're entirely correct. That is going to be, I think in almost all cases, that's going to be the better way of doing things. But what I can do is I can use my code to create the lookup table. So I'll create a second part of the tutorial where we will use a lookup table and we'll do things with the lookup table instead. But yeah, thanks for clearing it up, John, because I say I was slightly concerned that I was missing some better way of doing the pixel shifting, having not really done it before. As I say, in Chibi Akamas I just stored 2 copies of the sprite. In almost all cases, the character never flipped around anyway, so the sprite engine wasn't coded to do sprite flipping, so it just wasn't something that came up. So it's not something I've had to really think about. And to be honest, doing all of this, working on different systems every week and every day in some cases like this, is unfortunately kind of it's causing me to lose my focus. So sometimes I'm becoming a more simple pro. My abilities in Z80 are becoming less specialized and more general. And so, as I say, things like using a lookup table there, I'd unfortunately forgotten. But that, you're correct, that is something that would be definitely the best solution in almost all cases. But I can use the code I wrote today to create the lookup table. Okay, so we've got our set palette command here. We're going to store AF in the top byte. We're going to need to then calculate the other ones. So what we'll do, if we start this command with A as the palette entry, and then we rotate multiply it by 4. Now the only problem with that is going to be, if we've got 256 entries, we're going to go over. So we want to do STZ 65816 command. It does exist on a few of the 6502, I think it exists on. Okay, so we're going to do a store of 0 into ZH. We're going to rotate that left, and we're going to rotate any extra spilling bits into, it should be, it's not SRL, what's the command? It's ASL, isn't it? It's ASL. Let me just double check my cheat sheet here. ASL. Some of these, I've got these cheat sheets for all my different systems, and some of them, the 65816 one's getting, the text getting a bit small. It'll get to the point where they don't, using an A3 cheat sheet would be a bit ridiculous. So it's going to get to the point where I can't keep the cheat sheets, and I just have to have a spreadsheet open on my screen, which my normal machine has 3 monitors. It's got a 4K in the middle and 2 full HD vertical monitors by the side, but this machine can't drive all 3. Truth be told, it can barely drive the 4K one. So my plastic low-tech sheets are more useful on this machine. But generally speaking, I do kind of find the paper sheets a bit easier for that kind of information. But I've got everything on file on my hard drive here. So if the plastic sheets weren't available, I could fall back on the more high-tech spreadsheet option. So we need to store A in ZL here, and then we want to do LDA with 02, and we want to do so I'm just double checking we don't have an add command still, do we? Not even on the 65816. We still have to use add with carry here. Okay, so then I'm going to add with carry ZH, and then we'll do TAZH. So now our base is RGB. We're going to use 3 other registers here, so we'll use Z, H, ZB, ZC, and ZBCU. So that will be our triple for red, green and blue here, because why not? So hopefully here we've calculated our memory address of the palette entry in the accumulator. We've then added the base, which is AF2. That's the wrong way around, that should be 20. And then we want to do LDY +0 STA. So we're using square brackets here because we want to use a 24-bit long. And we're using the HLU triple as a memory address here, defined by the square brackets, offset by Y. So we load in ZBC. Increment Y. And increment Y again. And then we'll return. Well, there's no point running that because we've got nothing executing it. So let's put in some test code here. So we'll load A with whatever, 32. Let's load A with 32 and load triple ZBC. Now we can't use BCU here because BCU is actually the top byte of this triple. So, and then if we do FF00FF, that should come out magenta, I think. Let's have a go at that. Restart. Okay, that didn't work. Yeah. Sorry, I'm not checking my assembler window here. Unknown symbol load triple. This is case sensitivity. Load triple is a macro to load 3 consecutive bytes into the 0-page entries. Reference to unknown label ZH. Yeah, the case sensitivity is catching me out. I mean, this is one of those ones where you can argue that I'm wrong, and I wouldn't argue with that. I tend to be quite slack with my case sensitivity, so VASM, you can tell it to not complain about the case, and it will do that with this one. I don't think there's any way of stopping it being case sensitive, so it's punishing me for my slackness. Let's call it that. There we go. We've got a nice magenta there. I think that's in the wrong position though. Is that right? It doesn't look right. I think maybe my position's wrong. Well, anyway, let's we can test that. Let's load a second colour in. Red, green. So this time let's load colour 34 with yellow, and that should make it quite clear whether our code's working or not. Well, that didn't load into the right colour either. Oh, okay, well, I mean, one thing, I'm forgetting the alpha. I'm forgetting the alpha. Okay. Well, I mean, for one thing, I've got my colours wrong here. I've got them in the wrong order. So it's blue, green, red, not red, green, blue. Well, maybe that's no problem. We can swap these around. I guess that makes more sense anyway. Seeing as we're a little Indian. Okay, so we've got our yellow pixels there, but we're not storing to the right memory location. So what am I doing wrong there? So we're defining our H and our L here. We're multiplying our accumulator by 4 by shifting it to the left twice. Okay, well, let's try, instead of using numbers like 32 and 34, let's try just using some smaller numbers first. So let's use 4 and 8 here. Okay, and restart this. Okay, that's right. So I'm obviously making some horrible mistake with regards to selecting my memory address. So let's have another look here. I'm clearly being very silly somehow. I can't quite see it though. So yeah, okay, so that's that pixel there. Let me so it's so it's just a flat yeah, it's just a consecutive bytes here. Well, let's see if we can. So we're storing a 0 in ZH. We're rotating the accumulator left. Ah, okay, I know what it is. I think the load triple command is using the accumulator. I think that's the problem. There we go. There we go. Yeah, there we go. Yeah. Okay. So that was the problem there. I changed a H to an L when I fixed the cane sensitive, did I? Thanks for that warning, Science Explosions. Let me check that. I mean, the code does seem to be working, but it's perfectly possible that there's another bug in it. I think it looks all alright. I can't see it. I'm not saying you're wrong, I just can't initially see it. Anyway, the code's mostly okay for now, so well, I mean, say for this crude test of setting a few colors on the screen here, you know, this is like a consecutive palette here, so I'm now able to set the odd colors here. So what I'll do next, maybe I'll do this off camera. I will I'll set up a full palette so that we've got some colors to work with, and if there is another bug I'll fix it then. And the screen resolution isn't right. I mean, I've defined this screen, which basically I think the screen starts here and ends here, so that's a bit weird. So I'll try and configure a screen that starts at the start of the screen and ends at the end, and maybe I'll do a select pixel command, which allows me to select a pixel by XY coordinate. Once I've got those, what we can then do is I want to create a print character routine that uses the font that I use in all my other tutorials and gets the characters to the screen, because in theory, once I write my own print character routine, we'll be able to run this. Not that. Selected Vectrex. I can't compile for the Vectrex. So this is my example on the Super Nintendo, and this is my debugger test, which will show all of the registers here, and this will show a bank of the memory. And so when I'm having trouble and I'm not sure what my registers contain and things, I'll use this. Now this shows how out of touch I am now with all these different assembly languages. I said I thought there was a bug last time because this showed C, not A, and I was forgetting that the 65816 has two accumulators, an A and a B, and when they combine together they're referred to as C on this system, and rather baffling on other systems they're called D. That's just the way these things are, I guess. So as I say, it's there's two challenges here. Firstly, there's the learn the new system, and then the secondly is the, well, I'm planning to do some serious 65816 next year. I did some 4 months ago or something, but other things take priority, and the thing that it's not getting the priority just gets pushed to the back of the memory and starts unfortunately dropping out of the memory. So I mean, with all of these things, what I'm planning on doing is when the Christmas vacation comes up, I'm going to sort of do a serious knuckle down on all of this, and I'll be programming, probably 15 hours a day every day for the entire Christmas period, and I'm hoping that will allow me to properly start writing all the tutorials and things and getting everything, into the position that it needs to be. So, unfortunately, at the moment, doing the odd half hour here and there isn't necessarily enough. Okay, so we'll call out a time on that, but I do still have a couple of minutes left. So let's have a go at Juan's very clever suggestion of using a lookup table. I think we've got time to do that. So if I just get my Z drive back here, need my Z drive, and we need WinAPUge. That's the font size. As I've said before, unfortunately Win8 doesn't allow you to change your fonts within the set. There's no settings page in this version, at least. I don't think the new version's out yet, but in this version there's no font options in here. So I actually used a hex editor, and I found it was almost plain text. I think the code that was actually selecting the fonts for use in the debugger and the assembler. And so I was able to make the font really big, even though technically the emulator doesn't support it. So okay, so our alternative is going to be let's start with mode 1. And we'll define that with 256 bytes. And we will align it. And what's the align command? I can't remember. Is it 8? Is it 8 in this version for 8 bits? Or is it 256 for 1 byte? I can't remember. Let's see if the help tells me. It's different, you see. Win8 works one way and Vasamute it works the other. And so I work in neither very well. Align. I do like the online help though. Not online, sorry. The built-in help. I still remember back to the days of Visual Basic for DOS, where the help files entirely existed within the program, and the entire program was about 3 floppy disks. Nowadays, it seems the help is online, and when you try and find it, the pages are all deprecated, or you find forum posts that say, "Oh, idiot, you should have used Google first," and then give a link to the result, and then you click on the result and the result no longer exists, and you just think, well, thanks, you're insulting the guy, and now you're actually not helping people in the future, because rather than answering the question directly, you're just linking to other people's answers that no longer exist. So I do get quite frustrated by that. I understand people don't like answering the same question over and over again, but 256 I think we need to use here. So align 8 will be for Vasm. Align 256. There we go. So we need to byte align this so that we can be fast, and then we need to fill this. We can do this here. B here. Yeah, well, I mean, yeah, basically me too. The science and exposure learning as a kid from the VB help file. I mean, my first computer was the Amstrad CPC, and I learned basic. My dad taught me some bits, and from the manuals that came with it, paper manuals, of course. Now, Visual Basic. I mean, I stepped through all of the versions. We had the CPC Basic, then we had Quick Basic, and then we had Visual Basic for DOS, and then VB6 for Windows. And I mean, I think really all of it was the help files. I think I did have the internet at university when I was using Visual Basic for 6, but I don't really remember ever getting any real code samples from the internet. Maybe I did occasionally, but I think the vast majority of it was just trial error in the help files. But as I say, it just does seem a little bit of a shame that Visual Studio gets bigger and bigger every year, and the help files weren't something they were able to retain in some way. It's one thing I do quite like about Wikipedia is you can download the entire Wikipedia archive if you want to, and just run it offline, which is like, well, anything you can run offline, you can be pretty confident you're going to be able to still use in 30 years' time or something, which, let's face it, is what I'm doing now with the Z80s. It's 3 decades on. If it was all online documentation, who knows how much of it would have been lost. So, as I've said before, I did write an iPhone game, and I can't run my own iPhone game anymore, and that's a bit of a bugbear for me. So if we do LD A, D, and then we do flip mode 1. So we're going to write 256 flipped bytes into the lookup table, and then Now I think I don't need to do that, do I? IncD does set the 0 flag, doesn't it? So I can just do that. So we're flipping the bits of the accumulator. We're using D as our counter because we're using B and C here, and we're using HL as our destination there, and we're flipping all of the bytes. So now we should have a lookup table, and so instead of the bit shorter registers here, a bit short, so if we do push HL pop HL, no. Guess we've got to do it, haven't we? Now for now I'm going to do just load HL. I can just load H here, and then we load L with A, which is our lookup table reference, and then we do LD A from HL. So we're effectively selecting the pre-calculated flipped pixel from our lookup table according to the pixel we're looking up, and it's byte aligned, so we can set L to the pixel we're looking up here, I think. Let's try that out. Well, okay, so that's because we've still got that set for mode 2 there. And there we go. So that's worked then. So yeah, thanks, Juan. I'm sure I'm pronouncing your name wrong. I thoroughly apologise for pronouncing people's names wrong. I've lived in Japan for 8 years and I pronounce everything wrong in Japanese still. So you'll just have to accept that it's not for want of trying, but my pronunciation is unfortunately quite firmly stuck in the English pronunciation mode. So it's not something I'm happy with, but it's not something I can change either. Okay, so we've got a lookup table working here, and this will allow us to very easily just change the code in here. So if we flip this to mode 0 and run this now, well, that looks a bit wrong, but then of course if we change our sprite down here, there we go. So we can now flip in any mode for just the cost of that 256 byte lookup table. Now we can use BC, can't we? We can use BC for this. So if we load BC here, we're not using BC at all anymore. So if we load C there, and we can load the accumulator straight from BC here. And if we, instead of loading I think that's the right syntax for this assembler. There we go. So yeah, I mean, this, just in case you don't know, this is taking the top byte of the lookup table here. Now the syntax would vary depending on the assembly you're using. The 6502 compliant ones would do something like that would take the top byte. Now WinApe won't. I think Vassam might allow you to do that in Z80 mode, but WinApe certainly won't. Other ones you would do that to bit shift to the right 8 times, and some of them you just do a simple divide because it knows it's working in integers and it just forgets the rest. It does depend a little bit on what assembler you're using, what syntax that assembler likes. But anyway, so you can see there that yeah, that was the lookup table was the correct way of doing it. As I say, it's been a while since I've had to think on, you know, crazy optimization and the various choices you've got. So anyway, it's now 6:56 in Japan, so I will be preparing for work in just a few minutes. So at this point, I'm going to call it a day. Thanks everyone for joining the chat. I hope you found this interesting and found some amusement in my demented ramblings. Especially thank you to Juan for that suggestion of using the lookup table. Brilliant idea there. Yep, very good. The source... Yeah, I did John, the align trick, I did actually look at Operation Wolf. When I started developing, I looked at a few of the games that I thought were the best on the CPC for tricks, and it used it for transparency, background transparency. So it was looking up to work out how to do transparency. Now with Chibi Akuma's, I actually just used where all of the bits were 0 as transparency, which I felt was, it gave everything a black border, but that worked nicely for the cartoons. But yeah, they always aligned, they always are byte aligned, and byte aligning is best if you can because of the speed. And also if you've got lots of data, align it all together. Enjoying getting your feet wet in assembly, science exposure, well, that's great. The source code for this, I'll do some more work on it, tidy it up. It's going to be part of a tutorial coming up in the near future, so you will see it again. It will be free to download, and there will be a proper tutorial on it once I've got it all code commented and I've had to think about any of the mistakes and things. If you're really urgent, if you want to use it all of a sudden and you can't wait that long, just drop me an email and I'll get it to you. As I say, the next live stream will be at 6 o'clock Japan time. That's 10 o'clock UK time, I think, on Saturday. We'll be playing some games. So, you know, if you're around, just feel free to drop in. Really enjoy everyone hanging around. Absolutely amazed if anyone's willing to listen to me ramble on. And as I say, it's really good for me because, you know, the code we wrote today is going to be a tutorial, so it's not really taking me any time even. So thanks a lot. You take care now. I hope you all have a good evening or night or day or whatever time zone you're in. Thanks for watching and goodbye.